Penetration testers can create a lot of tools using TCP client. Now the big question is, what can I do with a TCP client? The options are endless, but I'm going to give you a head start what you can do right away after finishing this demo. In our example, we will develop a practical banner grabbing application and a port scanner at the same time. Yes, I will always keep my promise and show you practical examples instead of just showing you the academic principles. That's not it. You can even develop your own vulnerability scanner if you want to by extending the functionalities of the application. But how, Gus? Well, it's so easy. If you have the list of ports and services, then all you need is a vulnerability database saved on a file, and you match it with your results. Wait, I'm not done yet. You can even call Metasploit and start exploiting these vulnerabilities. A penetration testing application from A to Z. Like I said, the options are endless here, folks, and I leave the imagination for you. So let's get started. At the command prompt, I will issue the list command to see the contents of this directory. As you can see, our program name is called portscanner.py. First, let's see how to use our TCP client program by adding the help argument after the program name. The application will offer the full help for anyone who's using it. Just by reading this section, I know that the -a argument is for the target IP address, and the -p is for the ports to be scanned. Let's give it a shot. Start with the Python keyword, followed by the name of the program, like we just saw in the help section. The -a is the address of the target host. Finally, the -p argument is the list of ports that I will be scanning. 21 is for FTP, 22 is for SSH, 80 is for web, and an invalid port 99. Finally, press enter. The output should tell you if the port is open or closed. If it's open, then we're doing a banner grabbing to know the application name and the version number of the server. Here we can see that port 21 is open and the FTP server is using VSFTPD 2.3.4. Next, for the SSH, we can see that OpenSSH is installed. After that, port 80 is open and the web server is Apache version 2.2.8. Finally, we can see that port 99 is closed. Alright, let's jump into the source code and see it in action. Here at the top, you can see that I imported two libraries. The argparse is for parsing the arguments, and the network sockets library is used to develop TCP client functionalities. Note here that I'm importing all of them by using the star character at the end. As usual, the application will start here and call the main function. In the main function, the first line, I'm declaring that I will be using the argparse library and instantiating the argument parser object. Here I'm defining a custom message that the application will show in case someone typed help before using the application. In the second line, I'm adding the -a argument. Here I'm also giving to the user the option for adding --address not just -a, followed by the type of the argument, which is string. Finally, I'm defining the message for the help section. On the third line, I'm doing exactly the same thing, but for the port numbers that we need to define. Next, I'm declaring the args variable to parse the arguments of the address and ports by using the parse args function. In the next two lines, I'm using the args variable to store the values in the IP address and port numbers variable. The first one is easy. I'm just storing the args.address in the address variable. The second one is a little bit trickier. In fact, I'm splitting the port numbers and storing them in an array so I would be able to access them separately in the next function. Finally, we call the port scan function by passing the IP address and the list of port numbers to scan. Let's step into the port scan function. This function receives two variables, the target host and the list of target ports. The first thing it does, if someone entered a domain name instead of an IP address, is to check if that domain is valid or not. I want to share with you a trick that I use a lot while I'm programming. Let's say you are in the middle of your function and you want to test an idea. The best thing to do is to go to the Python shell and try the command yourself. First, click on the Python shell tab. Let's try this one. I will import the sockets library. Then declare the variable target IP by using the getHostByName function. Because the host is valid, I got the IP address of my personal blog website. Going back to the port scan function, we check if the domain is valid. If it's not, an exception will be thrown, and we print a custom error message and exit the application with exit 0 function. In the next line, we try to resolve the IP address to a domain if possible by using the getHostByAddress function. So if this is possible, I'm printing the resolved address. If it didn't work, that's okay, we can still proceed further. Let's see how it looks in the Python shell, so we can understand it better. Since I already imported the socket library, I don't need to do it twice. I will declare a variable called target name and call the function getHostByAddress. We can see that this IP address 8.8.8.8 was resolved to Google DNS server. Let's see what happens next. After that, I set the TCP timeout value to 10 seconds. Next, I call the connection scan function for each port number in the array of target ports that we created earlier in the main function. A quick note here. You can use multi-threading if you want. Let's say you're planning to develop this application for a larger scale, like for example to scan multiple IP addresses. But for this scenario, I will not need it at all. Now comes the turn of the heart of TCP client functionality. In fact, if I would only teach you how to create a TCP client, this function is the only thing that you need. But my goal is to show you not only the TCP client functionality, but how to leverage this into the next level. This function receives the target host IP address and a single port number. We start by trying to create a TCP network socket using the socket object. The AFINet means it's IP version 4, and the sock stream means it's TCP. We store that in the connection socket variable. Next, we try to connect using the connect function to the server and by passing the IP address of our target host and its port number. This is it, folks. We just achieved a TCP client in 2 lines of code. If the port is closed, an exception will be thrown. If not, we print that the port is open and we call the print banner function. Before I jump into the banner function, pay attention here that I'm always closing the socket object variable. It's a good practice not to keep the socket open. Alright, let's check out the banner function. This method expects 2 arguments, the connection socket object and the target port. In the first line, I check if the port is 80 for a web server. Then I will send a special message to get the server banner value. Else, I will send a random text. In this case, it's a new carriage return that is represented by \r\n. After that, I will wait for the server to send me back the banner and store it in the results variable using the receive function. And by specifying the number of bytes for the buffer size. If everything is successful, we print the results. I'm using here the str function to make sure to convert the results to a string. If we couldn't get a banner, then an exception will be thrown. So we print that the banner is not available for this port. We're done until this point. Now you can see the power of Python and understand why security professionals use it. Because it's simple and so powerful.